So check for deflection, we had stopped up till here. We had checked for the shear and the check for deflection was remaining. So for this we need to check L by D actual by L by D basic. So L by D actual comes up to be 15.92. The formula for L by D actual, the length is 5000 and the D that you had calculated is 314. So L by D actual comes up to be 15.92 and L by D basic is 20. So your design is safe over here as L by D ratio actual is coming less than that of the basic. So your check for the deflection over here is safe. So note down everybody the check for the deflection and we'll proceed for the check for the development length. After completing, let me know. Check for the deflection. We need to do the next check, that is for the development length. Yes, done.
Done, ma'am.
Now we need to do the check for the development length. So for checking for the development length, you are having the formula that is LD required, that is the development length required. The formula is given as 0.87 Fy into 5 upon 4 into tau BD. So 0.87 into Fy, the diameter you have taken at is 16, then 4 into tau BD. Tau BD you will take it as 1.6 into 1.2. So calculate the development length, required development length. Tau BD is nothing but the design bond stress, and it is on the clause number 26.1.1. For the various grades of the concrete, the design bond stress is given in your IS code, IS 456-2000 on the table number 26.1.1. Okay, done up till here.
Done, ma'am.
Then after calculation, you will get it as 752.18 mm. So LD, that is development length required, that is 752.18 mm. Support width we are going to assume, that is BS, we are going to assume it as 300 mm. The moment you had got, that is 67.50. In the earlier step you had calculated the moment. So the value for the moment is 67.50 kilonewton meter. Now you need to calculate the shear force. That is, shear force is denoted by VU. So you need to calculate the shear force. And the formula to calculate the shear force is WU into L by 2. Already you had calculated the WU in the earlier step, that is the load, ultimate load. So the ultimate load is 21.6 and the length is given to you, that is 5 upon 2. So you will get the shear force, that is 54 kilonewton. And after getting the shear force, you need to calculate L0, that is BS by 2 minus X1 plus 13.5. So BS we are consider it as 300. So 300 by 2. X1 is nothing but the spacing. We are consider it as 25 into 2 into 13 into diameter of the bar. So diameter we are consider it as 16. तो इसमें से हमें वैल्यू मिलती है 308 mm. So solve up till here. After completing this one, we'll proceed further. Yes, done. What is L0 over here? L0 is nothing but the length of anchorage bond at the center of support. Length of anchorage bond at the center of the support. Yes, what is X1? X1 is nothing but see your previous diagram, उसमें आपने spacing कितना लिया था? 25. Oh wait. See this one, 25 millimeter spacing you have considered over here. So that is the value for the X1, that is 2 into 25. So everyone had got the value for the L0, that is the length of anchorage bond. Sorry, the length of anchorage beyond the center of the support. Okay, done. Everyone had got the answer.
Yes, ma'am.
Okay. So 1.3 m1 by VU plus L0. So just substitute the values in the above formula. So This formula is on the page number 43 of your IS code. The formula for the LD is in your IS code, that is IS 456-2000. So 1.3 into M1 by VU. M1 already you had calculated, that is the moment capacity due to tension reinforcement. Already you had calculated the value for the moment. So that moment value you have to substitute over there. Then upon shear force, that is that now just now you had calculated, plus L0, that is 308. So 0.308. So you had got value, that is 1.933 meter. When you will convert it in mm, it will be 1933 mm. So the development length required will be less than the development length available. So here your design is safe for the development length. The formula for BS by 2 minus x1, that the formula itself is there for the L0, that is the length of anchorage जो आप calculate कर रहे हो, length of anchorage beyond the center of the support, that is nothing but the L0. तो L0 का formula ही बोलता है BS by 2 minus x1 plus diameter 13 into 5. So the form that is itself in the formula only. That's why you are going to subtract over there. See, refer your IS code IS 456-2000. After completing up till here, let me know so that we can proceed further. Okay, completed up till here.
Completed, ma'am.
Okay. Now steel details for the beam. So now this is the detailing part. So as you can see over here, this is the 300 wide beam, and this is 8 millimeter phi diameter bars are over there. That is the 2 for 8 phi and the 14 for 6 phi. And this is your total length, that is 500. And again, 2 leg stirrups of 8 is provided over here at the rate of 150 center to center spacing. This is the steel details of the beam B1. That is the detailing part, that is the reinforcement detailing for the beam B1. And again, this one is your detailing. As you had seen that the 4 bars are provided of 16 diameter, and the 2 leg of 8 stirrups at the rate of 150 center to center. And the size is 300 by 350, and the corner stirrups is of 8 diameter again. So just note down this detailing for the beam B1. Do the detailing properly. And after completing, let me know. So separate marks are being provided for your detailing part. 3 to 4 marks are being assigned for the detailing. Yes, completed.
Yes, ma'am.
Okay. What about others? All the others are also done. Should I proceed further? Should I scroll it down? Yes, completed or not, Tanveer? Okay. So do this also, and after completing, let me know. Okay, completed. Should I proceed further?
Yes, ma'am.
What about others? All the others are also done. So here we had completed the design for the beam and the slab both for these particular sum. Now we'll proceed with the next sum. Yes, everyone is able to see the screen. Is my screen visible to everyone? So this is the second problem of the flooring system. So in this particular problem, in the first problem we had solved for the slab as well as for the beam. The slab was two-way slab and the beam, and we had done designing for the beam as well as all the reinforcement detailing for the beam section. Now here your plan is slightly different. So in this sum you have to design the slabs S1 and S2 along with the beams B1 and B3 for floor to floor system as shown in figure. Consider the floor finish as 1.5 kilonewton per meter square and the live load given to you is of 3 kilonewton per meter square. So the floor finish is given to you, that is 1.5 kilonewton per meter square, and the live load is given to you, that is 3 kilonewton per meter square. And the grade of the concrete is being given to you, that is M20 and Fe415 steel grade is given to you. And the internal beams is carrying a wall load of 120 millimeter thick. Internal beams thickness for the beams is 150 millimeter and the 3-meter height, while the external beams carries a wall load of 230 mm. So internal beam carries a wall load of 150 mm and the external beams carries a wall load of 230 mm. And again it is of the size 3-meter thick. So first of all note down the questions, then we'll proceed for the plan. In this particular sum, they have told you to design for the S1 and S2 and for the beams B1 and B3. After completing the question, let me know. Okay. Yes, all the others are also noted. Should I proceed further?
Yes, ma'am.
Okay. Okay. So now we'll proceed with the plan. As you can see, here one plan is given to you, and in this plan, the slabs S1 and S2 is given to you. As you can see, this is your S1 and this is your S2. And as you can see, it is a 3-span plan. This is your span 1, 2 and 3. So here they have told you to design for S1 and S2 and for B1 and B3. So as you can see, it is of the total size, that is 6,000, and this is of the size 2500, 2500 and 2500. And the thickness given to you, that is external thickness is 230 mm, and the internal thickness of the wall is 150 mm. And the height is given to you, total height is given to you of the wall, that is 3 meter. So just note down the this one, then we shall proceed for the design of the slab S1, S2. Just draw this plan. After completing, let me know. Okay. Okay, can you tell me which type of the slab is this? By saying which type of slab is this? Simply supported or what? Which type of slab we are going to consider? One way. Yes, continuous. So first of all, will calculate for the depth of the slab. So for calculation of depth of the slab, can you tell me what is the formula for calculating the depth of the slab? because already you had designed the slabs for one-way as well as two-way slabs in your earlier semesters. So I hope everyone is knowing for the formulas to calculate the depth of the slab. So for calculating continuous slab, what is the formula to calculate the depth? Yes, anyone from you?
Yes, ma'am. L effective is equal L effective divided by 26 into modification factor.
Yes, L effective upon 26 MFT. MFT is nothing but the modification factor. So modification factor we can assume it as 1.5. From minimum 1.2 to 1.6 we can assume it. But here we are going to assume it as 1.5. So for calculation of depth, we will take L effective upon 26 MFT as it is a continuous slab. So MFT we are going to take it as 1.5. So as we are going to now, can you tell me what is the value for the L effective? After seeing the diagram, L effective, what will be the L effective? Yes, anyone from you? L effective. When we are going to calculate for the depth of the slab, L effective.
2500 shorter side.
Yes. We are going to consider
2500
this.
shorter side.
Yes. We are going to design one way slab for every time for the shorter side. So L effective हमेशा छोटा side ही रहेगा, and as it is from the center to center only, so we will consider L effective as 2500 upon 26 into modification factor, that is 1.5. so इसमें से हमें depth मिलेगा 64.1 mm. Now we are going to assume the cover as 25 millimeter. So D will be 64.1 plus cover, that will be 89.1 millimeter. So you can provide a depth of 100 mm and the depth you are going to get it as 75 mm. So do for the step 1, that is calculation of depth for the slab. So solve up till here. Okay. All the others are also completed. Should I proceed further? Yes. What about others? All the others are also done.
Yes, ma'am.
Okay. Now we'll proceed for the next step. That is calculation for load. So here we need to calculate dead load and live load separately, as we are going to calculate for the bending moment and the shear force. So first of all, we'll calculate for the dead load. So for dead load, you are going to consider the depth. So your depth is, how much your depth? Depth is your 100. So as it is 100 millimeter, you are converting in meter. So it is 0.1 into density. That is 25. तो इसमें से आपको सेल्फ वेट मिलेगा, that is 2.5 किलो न्यूटन पर मीटर स्क्वायर, and the floor finish comes up to be 1.5 kilo Newton per meter square. So the total load will be 4 kilo Newton per meter square. Then you need to calculate the factor load. So factor load will be dead load into 1.5. So dead load आपको कितना मिला है 4. So 4 into 1.5 आपको factor load मिलेगा, that is 6 kilo Newton per meter square. Then live load is given to you in the question itself. So live load कितना दिया था क्वेश्चन में? Live load is given to you, that is 3 kilonewton per meter square. So factor live load is 1.5 into 3, that is 4.5 kilonewton per meter square. So do the calculations for loading for dead load and live load. Yes, everyone had completed up till here. Everyone had got the answers for the factor dead load and factor live load. Factor dead load will comes up to be 6 kilonewton per meter square, and the factor live load comes up to be 4.5 kilonewton per meter square. Then in the third step, we need to calculate shear force and bending moment. Okay. So I think all the others are also completed. And if you are having any of the doubts, you can ask. Yes, any doubts you can ask. Hope everyone clear up till here. Everyone understood up till here. Now we need to do the calculations of bending moment and shear force. So for calculations of bending moment and shear force, you need to refer your IS code, page number 36 of your IS code, IS 456-2000. Wait a minute. See, refer your IS codes. Yes, are you able to see my IS code? Oh, wait, I will share it. So on page number 36 of your IS code, there are the coefficients. There are the different coefficients, that is for the dead load coefficients and the live load coefficients are there. So refer your page number 36 of IS 456-2000. Yes, are you able to see? Wait. See this one. This table you have to refer for calculating the bending moment and the shear force calculations. Here there are, yes, everyone is able to see the screen. Here the types of load is given to you. That is the dead load and the live load is given to you, and the bending moment coefficients. No. Now my screen is visible. This is page number 36 of your IS code, IS 456-2000. So as you can see over here, this is the bending moment coefficients and shear force coefficients. Yes, how many of you is being knowing how to calculate the bending moment and shear force calculations by using these coefficients, that is the dead load coefficients as well as live load coefficients? How many of you is being knowing how to calculate bending moment and shear force? Okay. Yes, Farah. So you can do the bending moment and shear force calculations. What about others? All the others also being knowing? how to do SFD and BMD calculations by using these coefficients? Okay, so you can do the next step. We are running short of time. Last 1 minute is there. So you can do this, and those who are not knowing will see by tomorrow. So those who are not given the attendance, give your attendance in the chat box. And those who are knowing this, how to calculate the SFD and BMD by using these coefficients, dead load and live load, they can proceed further. And the remaining students, we will see by tomorrow. And if you are having any of the